Today we will discuss a few important points: self potential energy of a shell and self potential energy of a sphere, interaction potential energy between two shells and between sphere and shells, all those stuff. So first we will begin with the self potential energy of a shell. Of a charged shell due to charges, right? Okay. Now, we just have a brief recap on potential energy of a system of charges. So, how do you define potential energy of a system of charges? It's like this: potential energy of a system of charges is equal to the external work done to assemble the charges in their own place from infinity. Okay. So, suppose this is a charge q1 and q2. So, what is the potential energy of this system? So, first you bring in q1, obviously no one else is there to oppose you to bring this q1. So, here to bring q1 the work done is 0. Now, bring in q2, q1 will oppose. So, what you do is this, the work done to bring q1 is 0, to bring q2 is how much? K q1 q2 by r. Or what you do is, you know, potential at this point multiplied by q2. Obviously, potential is the work done to bring unit positive charge at this point from a large distance. So, multiply that with q2. So, you have same thing, k q1 q2 by r. And if you bring one more charge q3, then what is the work done to bring q3? Say this is r dash, r double dash. To bring q3, due to q1 the work done is q1 q3 by r dash, due to q2 it is k q2 q3 by r double dash. Okay. So, this was a brief recap. Now, we will calculate self potential energy of a shell. That means this is a shell supposed to be a spherical shell, uniformly charged. Right. Yes. So, charge q of the shell. So, its radius is equal to r. So, how do you charge it actually? Say at a time t the charge is small q. This is the final state you have to achieve, right? So, let at any time t, or you do not need that time at all, say in a stage you have this charge q and you bring dq from infinity. So, here it is infinity, large distance away. So, some external agent, you are working hard, you carry this dq from large distance and gradually move to the surface of the shell and keep it, and then again you move to infinity and bring this dq again and again. So, it goes on. Okay. So, what is the work done to bring dq? So, when the shell has charge q, work to bring dq from infinity to its surface, surface of the shell is kq by r, potential multiplied by dq, right? So what is the total work done? Total work done to charge. So self potential energy of shell is equal to net work done. Net work done is equal to integration of kq dq by r. Now this small q starts from 0 and ends up at capital Q, the final charge. So you get kq square by 2r. So self potential energy of a shell is kq square by 2r, right? Okay. Now we will calculate the self potential energy of a solid sphere, uniformly charged solid sphere. Acha. Here, as you put on charges, the radius keeps on varying, so it will increase. So that is the final state. You have charges throughout its volume, so radius r and charge q. Okay. Final state is this, radius r and charge q. Okay, I forgot to write this. Self potential energy of shell of radius r and total charge q. Here also the self potential energy of uniformly charged solid sphere of radius r and charge q. Now from infinity you have to bring in the charges, but at a certain time it's a smaller sphere. See, a smaller sphere, it's having charge throughout its volume. Presently it has charge q and you bring in dq from infinity to its surface, right? So as you know that the volume charge density is constant, so q divided by 4/3 pi r cube is small q divided by 4/3 pi small r cube. Therefore q by small r cube equal to capital Q by capital R cube. This is the relation between radius and charge. Okay. Now, so at present its radius is r and charge q. So the self potential energy we can directly write. We will have to integrate what? See, at this point, say let's add one more step. At this point, so work done to bring dq, work to bring dq on its surface is k small q by r times dq, right? Now you have to integrate on this kq by r times dq from, there are two variables q and r,